This world is broken. The science is outdated, the math is incomplete, and the people are so blinded by greed that they cannot see the way forward.
Wait. You're not thinking of intervening, are you?
It has to be corrected. Knowledge is not a commodity. It has been and always will be their future. Standing in the shadows is no longer an option. We have to teach them to share freely without fear of retribution.
There is too much to teach for just one person.
I know. We will have to recruit more people who think the right way. The people who have been shunned by the mainstream. People who have the passion in their heart for the science.
How do we find all of these people then?
We create an open forum to discuss ideas and build ties. We let everyone have a voice, and we never let greed dictate our path.
What do we call it then? Oh, I got it. The Fringe think tank.
The Fringe think tank it is then. Now let's give them back their destiny and open it up to the world.
Hello, everyone. My name is Nathan, otherwise known as Old Man Bills. Guys, we got a good show today. Hey, Ben, how's it going?
Hey, what's going on, everybody? How you doing, Nathan?
Doing great, man. We're going to be talking a little 0-point energy, but first, we're going to get into a little bit on the energy we're producing out of the Tesla coil, just so it's going to coincide with the 0-point energy. Ben, how's your projects going?
My projects are going pretty good. I got a couple more components in that Sean helped me out with Throne, and I put together a new Lightning Thief board. And this time, I'll show you guys later, when I'll go over a short presentation for you. But I put together like a makeshift swappable board. So, as I was saying, I want to make sure all those essential components are swappable for you guys. So you can easily change them out or upgrade them or whatever, mess with it. I just, I cut a bunch of Arduino female jumper wires, and then I just soldered them onto the board. So I just have them littered all over the board. It's really Frankenstein-ish, but it works. So I'll show you guys, and we got a couple of cool updates from Michelle that I wanted to show you as well, and hopefully get him some more subscribers.
Right on. Yeah, I just talked to him yesterday. We were talking about scalar. Really cool, man.
Yeah, he's working on some really awesome stuff with scalar. Yeah, we got some cool videos to show you guys.
Right on. I want to say thank you to Ian. He's got my name on it right here. And he sent me the board.
Oh, yeah. Yes, Ian. I got mine as well.
I just got it in today. I'm looking forward to hooking up to a ZVS and see exactly how easy it is to use to get that sucker in tune. So, yeah,
Look
man.
how classy it is and well made. It's so nice.
Dude, this thing has got like, hold on. Let me showcase it here.
Yeah, it's very well built.
So, yeah, it's got it in the box here. And super clean, right? So as you switch through each capacitor here, you're able to put a different value in there. I probably got it upside down. Sorry.
Oh, there you go.
There we go.
Oh, it's such a cool piece. And then look at the box. Look at the box. It's got your name on it.
That's so cool, isn't it?
I know. Yeah, massive shout out to Ian for that. We really appreciate that. That's going to help us a lot.
Oh, absolutely. Ian, you're so awesome, man. This is going to be cool.
And it's a master. Yeah, and it's a master Evo board, isn't it?
Yes, it is. It's a Master Evo design in order to switch capacitance. And when you see Ian demo it, he starts flipping through it, and then he knows exactly when he's in resonance. And God, it was the most beautiful thing ever. So,
yeah, that's really cool. Yeah, super thanks to Ian, and that's awesome. We have a Master Evo board built by the legendary Bog Irish.
That's right, Bug Irish in the house, man. Taking care of stuff, man. So anyway, Ben, I have a presentation for a little while. I could put it up, and then we'll get into a little bit of 0-point, and then you can close the show and tell us everything that's going on. Is that all right?
Sounds good. Yeah, sounds good.
All right, let's get into it a little bit, guys. For those of you who are classic Steinmetz, I'm sorry, I'm going to break a few rules here, but I'm going to have to. And it has to do with Michelle and I talking over the scalar and understanding of it, and then exactly what's going on in the experiments that I'm working on. So anyway, without further ado, here we go. I did a video a while back describing what's going on with my Tesla coil when I put a rod down the center. I was told that it was static electricity. However, I don't believe that in any way. And there's a reason for it. I've done tests, so let the test be the answer, of course. But there's other reasons for it as well, and other tests that people have done. So let's be fair and take a look at it, and we'll draw each one and see what the merits are. And I think there's a very simple reason why it's not static electricity. So we have our Tesla coil here. We have a rod that goes down the center. Now, when we look at Steinmetz, we see this around. We bring it out. We've all seen this. We know this to be the dielectric is the dots. That's the magnetic. What's the problem in the equation? Well, the inside isn't the magnetic. You see, these right here are scalar. They're not magnetic. Now, I know, don't go against the classics, but you have to take it how it builds out when you build your project. And there's a very specific reason. So if I said it was static, right? All right. We're going to take static right here. What do I have to do? I have to take my voltage, and I'm going to bring it up to, say, 20,000 volts. Now, my amperage has to be that or lower for my amperage. So 20,000 volts at 0.0924 amps or lower in order to get a static volt. What that means is basically you take a DC flyback, take a second DC flyback, you run the positive here to the negative here, and then you get the negative out here and positive here, and it'll create this. Or you just take a Wilmshurst. That's real simple. Either way, you're getting static. Now, static has certain properties to it. This table is malamine that I'm standing in front of. If I create static electricity, it will run across the malamine. If I took a PVC pipe, it'll run right across the PVC pipe. You see, it's an uncontrolled voltage. It doesn't get pulled in by the amperage. So, it gets spread everywhere. If you could get this number down to 0, could you get the field we're talking about? The problem with that is very simple. You have to have volts plus amps equals magnetism. You do not have this without both of these. Therefore, you have no running electricity on a wire without both of these. Now, that's one of the biggest problems with the whole theory. You cannot get this to 0. You will lose everything. It does not come out at 0. Now, we build electrodes. What is that? You take a side of a material, you're going to permanently charge it with voltage. Therefore, every time you put your hand over here, the little hairs on your hands or arms will stick up. But it still has an amp in it. Some form of amperage is still in this. You couldn't wipe it out. You get an electric. But it has certain properties. It will always pull up the static in your arm. All that hair will stand up. That's why it cannot be static. Why do I call it scalar? So, I know Steinmetz called it the amperage or the, which it is the amperage, okay? But he called it the magnetic. Well, it can't be the magnetic because you have to have volts and amps to create the magnetic. You see, the magnetic is not the root. It is the combination of your volts and amps. That's why it can't be that. So it has to be something else. So then, why would I call it scalar? You see, the energy works this way. It's produced in a field that goes out everywhere. Then the field stops. Apparently, it looks like it stops, but it really doesn't. It has a null zone. Then when you have another spot that picks it up, it builds out a voltage as well. And then there's a null zone in the center, just like a planet in the sun. It's doing the same process here. It's scalar. So now when we look at it, we go, okay, you have this here. I'm going to tell you this. Here it is right here. This is clearly our voltage field. This is our amperage field. This is our wire. Okay? Now, this is why this is important. This field comes in right here. Now, I know this is controversial to some people, but this is exactly the way it works. This energy can be produced in this manner, and it has certain properties to it. I took this gravity flyer, and just understand this. If I put my Tesla coil here on this center plate, just the rod down the center right to here, and I put static electricity on this plate and this plate down here, regardless of magnets, regardless of any of the other stuff. Just that. We're just producing fields out of it. Now, this voltage right here, that's here, I call scalar, is producing a field around the whole thing. Now, when this comes on, it stays inside of it. It's holding it back. You see, one field is inside of the other. That's why it's working that way. Now, what if we reverse it? Everything you do in this, you have to reverse. Let's put the Tesla coil, run it here, right through the coil, right down the center, right to the bottom. Then we're going to run our static electricity here. What happens? This disc and this disc combine together and they make one field that comes out like a bubble and forces this field to the outside now. Now that field itself stays on the outside. It does not come to the inside. You see, you're able to move the static field based on which way you set this thing from the inside to the outside. It's all based on how you build it. So, I know one field holds in the other. That's why I know this is an inverse. Right here, I've inverted the field. Not many people have seen an amperage field. That's the interesting part. Have you? You see it in scalar. Simons didn't get it wrong on how he drew it. Scalar builds from a center point outward, and the voltage on each one of them goes down. So if you start at 9 volts, then you go to 8 volts, then you go to 7 volts, 9, 8, 7. Just like that. That's how scalar works. It also works with temperature. Temperature and frequency are scalar. When we see the amperage field, it's temperature. Now, that temperature, when we look at magnetics now, the closer on a wire here that I take my amperage field and my voltage field and I connect them, the heat goes up. That means that there's more amps in it than volts. But when I have more volts than amps, that heat will go down. It's predictable because this field is scalar. It's 100% predictable every time. Now, what is the property of scalar that you get that you know that you're in that field? You see, this is not very apparent in a scalar field. So let's say I built this right here, just a little tube, and I'm going to wrap it copper wire. I'm going to hang a magnet right here. If this had a ton of volts and amps in it, more amps than volts, okay, then this right here should pull this way or push, however you want to see it, either way. The problem is when I did the test, it didn't. It didn't move at all. You could put it over it, it had zero effect to the copper. What does that mean? That means the one that we call the magnetic field is not. It's mislabeled. It's a scalar field. The scalar field has little effect on a magnet. If it was static, this whole thing would have static all over it. All over it. I couldn't get near it without getting shocked. But it doesn't have that feature. It acts as pure energy. Pure energy is scalar, not magnetism. Now, if you can understand that, let's make it more complicated for you. If there is no magnetic field, let's draw this again. Hang my magnet here, take a neodymium 52 and do it. How do I move that? How am I going to move that if I just told you this is scalar? And I told you the property of scalar is that it does not have the field that you produce in a magnet. So it does not have that effect where you have one on the other and then one forces upon the other. That's gone. How do I get this to move? The only way to get it to move, if I knew the frequency of the metal itself, now I can move it. It is simply a music circuit added to my Tesla coil. That's it. You don't have to make it music. All you have to do is make it frequency. I'm going to add a frequency to this. Now, this will move based on the frequency I added to this, because now on my wire I have my scalar field here, I have my dielectric here, but now simply going to wrap it in a separate frequency. Now I can get this magnet to move. We should know what fields we're in. I'm telling you this only because this is exactly how the tests prove it out. If it was static, I would trap it in an electric, and then it would be able to pull up the hair on my arm. I should be able to take this field when I pull it from my Tesla coil and put it near my arm and have every hair stand up if it's static. The problem is it has none of those qualities. When I put it there, it is pure energy. It starts to interact with the actual water in my body. You see, that's how Tesla got himself to glow. We all look at the France experiment. He got himself to glow because he was in a scalar field. The only way to make it happen. It's the same energy he probably uses in his X-rays. It's a safer energy to use because the one we're using is destructive. So, I know this is a lot to take in. This violates probably everything that you guys think you know about everything, right? How did he screw up Steinmetz? How does he have a misunderstanding of magnetics? I know it. I know that's what you think. But I do the tests daily. I've proven that on my channel. I've shown the experiments of the magnet. Those things aren't there. You see, the only thing that screws up scalar is viscosity. So when I run it through mineral oil, it doesn't like to operate. When I run it through vegetable oil, it doesn't like to operate. But if I put salt in the vegetable oil, it'll eventually cross the field. Now, if it has any kind of liquid in it like water, it interacts with the scalar energy. You see, static electricity doesn't work that way. It has to be the reverse. So the field that I say in Steinmetz that he classifies as magnetic right here is not magnetic at all. It's scalar. It takes scalar plus the dielectric, or you could say it as the volts, in order to equal magnetic. A magnet is simply a dielectric that trapped the volts and the amps in it. It trapped that field. We do not recognize it because we do not play with it daily. I do. I've transformed this energy from hot to cold, back to hot. I've also turned things on with pure frequency. These experiments work because I know what field I'm in. You see, it's not that Simon's got it wrong, he just didn't finish out his work. That's it. That's my understanding of it. You see, if we get this understanding right, and we can all start to see it this way, it changes your understanding of anti-gravity. Now, it's not a subject people like to go into, and I do, so let's go into it a little bit. My good buddy Gerald showed a test. He put his coil, put a magnet, they put a little rod, just to keep it in the same area, had nothing to do with the test, and he simply added the frequency of the metal in the magnet. This is the magnet, this is the coil. And his coil jumps, goes up. If he reversed that same thing, put the magnet here, he's going to get it to jump. So what's the understanding? Okay, he works in scalar as well. Take this rock. This is a bad looking rock. I have it in a bowl right here. Yes, bad looking bowl. Whatever. I'm going to put water into it. The water itself penetrates the rock, goes in here. If I have any kind of quartz in here, let's just call the rock granite. I put this energy in there from my Tesla coil. Just like that. This rock is full of scalar energy now. Now, I need to add a frequency to it. Now, I need to add direction to it. Sound is movement. Got my little drums. I now have a band playing. I have my frequency added. This now goes to the ledge of the mountain. They knew it better than us. They didn't need the Tesla coil. Why? Because this energy is in the earth. It's right below our feet, and we don't realize it. The monks knew something we didn't. And hopefully when you guys understand this, you understand they didn't pull any tricks. They just understood it in a different way than we did. Anyway, hope you enjoyed this, guys. Have a good time in the rest of the show. Thank you. All right, everyone. Now, it's kind of trippy how this works, right? Now, I showed you an inverse there in order to get the scalar to come out. So it changes a little bit as you look at the fields. But man, magnetism is volts and amps together. It's not one field alone. And that's why it's messed up. I have a feeling that Steinmetz put this out and he was writing another book to explain that. And it's one of the ones that never got published. So it's not that he didn't know it. I'm sure he did. I just don't think he could have put it out because it goes against every law that they put out at the time in understanding this stuff. They didn't want you to know that there was another way to see energy. You see, negative energy, cold energy, whatever you want to call it, scalar, they didn't want you to know anything about it. As soon as you knew about it, the game was up. You now understood Tesla so much better. Tesla said it. He knew about it. But none of the rest of them tried to tell you about it. Not in this way. So hopefully this explains everything, guys. It's probably a better explanation. Static electricity is the worst thing in the world to play with. It blows out all your equipment. You never get your amperage down to zero. I've tried. It is just nasty. And it has a very, very high clean rate. There's none of that in this. This energy comes out as just a giant field of energy. And it doesn't produce any quality of static electricity at all. It is, like I said, pure energy. You put it into an orange, it lights up the orange. You put it into your burrito, it's got water in it, it lights it up. You can put it in a cantaloupe for all I care, it'll light it up. Watermelon, same thing. Anything you want that has water in it, lights it up. You can put it in a jar of water, lights it up. Put it in your mud, lights it up. Okay? This is truly the scalar, and we know because of the way it interacts with things. So when I was talking about the pillars and stuff, you have a pillar over here and you have a pillar over here. This is generally the way we do scalar. We have a rod with a big ball on the top. That rod goes right down the center of your Tesla coil, big ball on top, it goes to the other one. What did I just tell you that I did to my Tesla coil? I simply put a rod down the center. I didn't violate any law. I just did something that scalar usually does. And I produce a scalar field. Scalar fields work on temperature. So think about it. When you're running your experiment, what is the one thing that just about everybody fails on? They don't understand why their MOSFETs heat up. They don't understand the interaction between volts and amps. So when I tell you the frequency is really high and the amperage is really low, then we get into a static field. But when we get really high amps and we get really low volts, we get into a magnetic field. Now, static still has magnetic properties. It's not that it doesn't. It clings to everything. It's just not ferromagnetic in the same way that magnetism is. And that's what happens when you change it. But that's okay. It just means you better know it when you do it. No problems whatsoever there. It's a different kind of energy, guys. I wanted to point this out because we're getting ready to go into 0 point. And when you get into 0 point, you have to understand scalar and frequency. That's why I'm doing the next frequency test with all my Tesla coils you see behind me. You see, I can light one up without any kind of voltage or anything on that secondary coil. I don't have to put a driver into it. All I got to do is connect it to the ground. I can do it at 63 inches at will. Just understand what that means. That means that I just transferred energy from a primary Tesla coil with a driver to a secondary Tesla coil with absolutely no driver, just the number 2 coil connected to the ground, and with frequency alone, I turned it on. It produces volts and amps in it. Now, frequency is the most misunderstood thing because of that. How in the world do you get this thing to turn on with volts and amps inside of it with frequency alone? The answer is it must be in perfect resonance with the other coil. Then you're going to be able to put volts and amps in that secondary one. High RF is scalar. It produces the same exact thing. That ring, absolutely. So it's just like 2 tuning forks, not much different. The tuning fork sits in a box. The box actually produces a sound. The sound goes on to the next box. The sound then interprets it back into frequency and rings the next Tesla coil. We have no direction in this except for up in the Tesla coils. They're not pointed to each other. They're up. So it's got to ring real good. But because it's scalar, it's going to go and start up that next coil. So if I tell you the sun has multiple Tesla coils in it, and I tell you every planet has a Tesla coil, which there's more than that, then I'm telling you that frequency alone will be able to produce enough energy to kickstart everything else. And when you get things in resonance, strange things start to happen. When I tell you about the magnet, if I'm getting the frequency of iron, Gerald ran his project at 7.83. 7.83 is the same frequency of the Earth. Schumann resonance. Why in the world do you think it started to work? That is the only explanation possible. You see, he moves his dipole everywhere. So he's changing it constantly. So that's not necessarily it. He's trying to tell you, based on the way he hooks it in, that he's hitting a frequency that gives it magnetic properties again, because he's now adding frequency back to the other side of what he just created in there. In that dielectric that is that magnet, he added frequency to the other side of it. It's now moved. Now he's able to communicate with it. That's it. It's as simple as that. It's a better understanding to be able to get us to go to the next level. Now, let's go into 0 point. Here's the thing. You're opening up a field to get to the 0 point. What have we produced out of the 0 point? I tell you, Gerald's coil's got it. And I tell you that all the time. What is he getting out of his 0 point that we're not understanding? You see, soft iron core. He put a bunch of windings of copper wire on it. It's still not magnetic when he puts it in there. So you know he's got multiple layers of scalar going on. There must be 1,500 of them. Every winding he puts in there, he's getting another layer out of it. He gets a massive voltage out of it. When I explain to you how the fields work, okay, voltage, amperage, wire, inside the wire is where I move that voltage field. You open the 0 point, you get directly into the voltage. It's still in the system. You open up everything to get that voltage out. That's what's in your 0 point. I'm sure that it creates a plasmoid in there, guys. I don't doubt that it does once whatsoever. And there are different ways to do it. You can do a single dipole and open it. You can do a multiple dipole, which is north and south. It really depends on the structure that you put it in to build it. If you wanted to make a jet engine out of it or something like that, single dipole. You want to make a balanced system, top and bottom, you need both. Now, piezoelectricity interacts with this perfectly. What do I keep saying? It should be right around the center of the earth. Well, it's that piezo. It interacts with scalar beautifully as long as there's water. So it's an interesting thing. It's exactly how you get to the 0 point. It's what's going on in that coil. And it's the biggest eye-opener when you start looking at it because you start realize what he's doing. It's not like what we're doing. My Tesla coil puts out one frequency, guys. It makes one level. I need a second Tesla coil to make the second level. I would need a third one to make the next one. I can't get multiple layers out of the Tesla coil. You have to wind the wire in order to do that. Anyway, that's my understanding of it. I know other people say, nah, maybe not. The thing is, guys, I build it. All the time I build it. If you got something that built 0 point, by all means, I'd love to see it. I've seen it. I've seen the reactions to it. I've seen the interactions of it. And I can tell you what it's producing. Now we have to understand things a little bit different. Now, with that said, I can tell you the planet builds out that way too. So we get the same fields on our planet. I don't think people understand this. You're getting a scalar field underneath. We sit in a plane that divides the two. We're sitting in the static field, the hot field. It all depends on how many volts and amps are going on around us. But we're also in a saturation point, so we don't feel it. But when you get up in an airplane, you're going to feel it as turbulence, aren't you? We don't necessarily feel that on the ground because we're in a saturation point. The saturation point nullifies the part where you're thinking about. That's why we don't feel it here. All the properties are there. And when you go up in the sky, you're going to get massive turbulence. It's an understanding, guys. You don't want metal up there. You want aluminum. Why? Aluminum's one of those rare metals that aren't going to allow you to create a magnetic bond on it. At least not unless you really know what you're doing. But for the most part, you're not going to get it. So, anyway, that was my presentation. Ben, you there?
Yes.
All right, give me some questions, Ben.
Well, I wanted to touch on your comments on Steinmetz and just emphasize that it is probable that he continued his research and, further evolved his understanding, and we just don't know it. We don't have that public access.
Well, he wrote two, maybe three other books, and they weren't able to be published. The person, I think he was working for GE, they wouldn't let him bring it out.
That's interesting. Yeah, no, I quickly fed some information into ChatGPT to try to understand your concepts a little bit, the amperage as a field. And it's basically telling me that's a fascinating theory, and it basically holds true in a lot of aspects of physics and electrodynamics. So, I mean, I need to learn more about it. I don't understand it to the level that, I need to. But I'm hoping that you'll put out more videos in the future and start to explain this concept in more detail.
But think about the world, Ben. If I told you it was scalar, and then I told you how volts and amps work, and I brought up the voltage, and then the temperature would be less, right? Static electricity, you don't get a lot of heat.
Right.
So your mountaintops are cold, right?
Yes, and the top or the sky is positively charged, right?
Yeah. So now let's look at the ground. If I told you the scalar under the ground, what would that mean towards the bottom? I'd be producing more heat, right?
Right.
Now, if I told you that each level, Todd Giordano told us this, each level has its own frequency, even if it just changes just a little bit as it goes up. We are in a scalar field. A topographical map would be able to tell you the exact temperature versus frequency in each one of them.
That's interesting. No, that puts it into perspective. I like that.
Yeah, it's a little bit different. I mean, it was kind of a shock when I put the magnet over it, because I'm thinking, you know what I mean? We should have enough in this winding in order to produce a field out of it if there was magnetics in it. And when I put the magnet over it, there was nothing. So,
yeah. Huh. And it's interesting because when I use the Joule Thief, usually under the stereo amp, the configuration, when you have it in a set to a specific frequency, it will produce, electromagnetic field, but the Joule Thief doesn't. So I'm wondering if something like that's going on where it's producing more scalar.
with your Joule Thief, your Joule Thief's at hot energy. You know that, right? Ben?
You said what?
Your Joule Thief is in hot energy.
No, I did not know that.
Yeah, well, unless you flipped it and did you pull the negative through the system?
So I don't actually know if it's hot or cold that I'm using. I'm supposedly using the back EMF just like the Joule Thief's, but supposed to. But if it's working correctly, it will be using the cold energy. But I don't actually know how to measure that, because Michelle and I have been talking about how to properly measure, negative energy, and it's just I don't think I have the equipment to see it. You know what I mean?
Yeah, you wouldn't be able to measure it unless you convert it back.
Yeah. So, and I think Mike had a couple ideas of maybe I could, use a rectifier or something and measure it that way. But I still haven't had any luck measuring that. So I don't know. It's up in the air what's going on with the circuit at the moment. But I mean, it could be either, in my opinion. I don't know. But I'm hoping that when I get you a Lightning Thief, that you'll be able to, test with it and determine what's going on.
I'll tell you exactly what it is then, yeah. Because then I'll be able to put it on my stuff and see what it is. Somebody asked if I was a high school teacher. I don't know if that was to me, but no, I was not. Not a teacher at all. As a matter of fact, they put me in the not so smart classes. I didn't care to go to school, guys. Wasn't really into it. Life events were going on and I didn't want to be there. So, one thing about this. So, real quick, Ben, did I show you the temperature readings that come off of this thing?
No.
Okay, check this out. I'm going to show you this. The temperature, okay, so, oh, hit the wrong button. Okay, I hooked my camera up to it, and I wanted to see the temperature. Now, let me just set this up for you guys so you understand what's going on. I have my power source on the right. You see my ZVS on the left. My Tesla coil is right in front of it. You obviously see my oscilloscope off to the right. The circuit is on as soon as you see me click the button. And what will happen is I have it connected to my rodent coil. And this is why I want you to see it, Ben. When this energy is in that rodent coil, it's cold. This is the first run of my thermal camera. And as you can see, we got heat on the power source here. Now I just turned on the Tesla coil. You can see the heat in the board itself. The capacitors aren't hot. It's just the normal things that get hot on there. But my rodent coil, when it's attached, it's on right there. The light's on.
Wow. Yeah. Yeah. That's just further proof.
It's actively no heat. You can see the heat there, like a barely any, like a normal circuit. You can even see the lines going in. The one on the left right there is where you usually get heat up and stuff. Not a lot because I'm in a great oscillation right there. You can see the windings of the number one coil weren't hot at all. And that rodent coil is not hot. Not one bit. My hand is. Sorry, that's a bad shot. Right there, you can see it. Yeah, still not a lot of heat in there. Now, the cool thing is you can see the rod going right down the center. It is brass, by the way. You can see the color of brass right there. That's interesting. And hey, Ben. That rod right there, that's not a see-through camera. You're not seeing through the wall. That rod's completely identifiable the whole time.
Yeah, that's odd. I mean, I don't have a thermal camera to play with, so I'm not familiar with, but it does look off. Yeah, well, you can see it the whole time. It's not like it's... As you go down, you can start to see the rod going right down the center of it. Yeah, and you can see the hot components going into the, the coil, and it's not really showing any signs of heat on the Tesla coil. Well, this is the first time I run this thing, so I'll get better at it and try to do side-by-side with regular footage to make it easier. Almost blended in with the background temperature, the ambient temperature, Yeah, that's really awesome, isn't it? Yeah. I mean, I had a thermal, a thermometer, a laser one, that I was measuring the temperature of my coil, but I wasn't able to put enough energy into it to actually determine if it was going to heat up or not. The amount of energy I was putting into it was very, very small, so I don't think it would have heated up regardless. But I don't have access to that thermometer anymore, unfortunately. That was from my previous job. Yeah, well, this right here just kind of shows you, Ben, it's cold. We know that it's cold, and it comes off as cold. The only thing in there is high RF, so you're going to get a burn. There's no question about that. So the one thing I did want to do was put a regular cell phone camera next to it. So this one hooks to my camera on my phone, right? And I wanted to put a regular one right next to it. And if I could do that, then I could show the light lighting up and the actual amount of heat in the light. You know what I mean? Right. So it would just basically be a better view so that when we narrate and go through it, you go, oh, that light is on. Okay, so why isn't there a ton of heat coming from the light? Why isn't there a ton of heat coming from the coil? You know what I mean? And then I wanted to get the thing up on a stand, kind of like we were talking about a little soccer stand that holds it. Mm.
You know, like a soccer trophy. And then I want to get this thing humming. So in my coil, bad boy right here, these things, Ben, every one of these that goes around, I want to add a coil. Now, Michelle did this in his. So what I'm looking to do is I want to get the spirals, and then I'm getting that turn already, and I'm getting the cross field.
Oh,
So-
you're gonna wrap it around the inside of the donut. Oh, I see, the pickup coil method. You're gonna wrap the pickup coils. Nice.
Yeah, so-
yeah, that's really. I mean, honestly, that's from everything I've read, that's really the most efficient way to utilize the coil. You know.
But that's one of the things I'm not necessarily looking for the energy out of it because of that thermal cam. I'm looking for the flow.
So you want to, you want to be able to see that.
What I want to see is once I put those things in and I put them in a flowing pattern, you know what I mean? Basically, whichever way I want. If I want it to go that way, I'll put it that way or this way. You know what I'm saying? On every one of these, I want to see if it pushes a thrust out. I think that thermal cam is set up where I can see a little bit of it. It'll show like a wind. I'm hoping it shows that it's a little blurry. And
so
that
you
would
think
be,
it's going to push out a little bit of heat?
Well, you see, because
Or
the energy is flowing around it. So it's picking up the energy of the room and shoving it through it.
And through, oh, yeah, no, that makes sense.
So now, because it'll only show me the energy on the wire right now, but those other ones should be able to show me the flow. Now, if I could see that, the other thing I want to see if is it makes the vortex on the top and the bottom. I want to see when it blows in and out if there's a place where it holds it in a V on the top and bottom.
I wonder if, well, I was thinking, I wonder maybe if you had some kind of like a smoke or fog machine, you know, that you could blow right into the center. Maybe you'd be able to see a little better. I don't know.
I do have a fog machine. And I'll run it. I'll run them both at the same time, see what it does.
Nice. Yeah, no, just experiment. Yeah, see if you can see anything. Because, I mean, if your theory holds true, we should be able to see something, right? And I think you're onto something. So, and it you know, there are anecdotes of people who have utilized these ABBA coils and rodent coils correctly. And, you know, there's this one guy in his lab, and he's smoking a cigarette, and he blows it near the coil and is running, and he sees the vortex being created with the smoke. So,
well, I always told you the rodent coil is an example of the field itself, of the energy of it. And that's why I think when I put that in there, you're going to see all the flows. And then, like you said, if it shows that vortex coming out of there and that vortex has no heat, you know what I mean?
Right.
It pretty much tells a story. It means that once you wind this thing as a flat coil, and you're going to get dimensionality out of it based on the rotation of the wire itself. So if you said a triangle, right, and you built a triangle in there, then the energy has to flow from the first starting point through the entire triangle and back, right? So if I do that, and then I bring it down and I build another one, okay, or do 180 and then another one, what I'm essentially doing is each time that I do it, I'm creating another layer of scalar. As long as they don't cancel out and they act as a diode, I'm good. I can it'll change the frequency because each wrap will have a different frequency going up or down. So it's kind of all together understanding. I wish Gerald was here to throw his 2 cents in it because that man knows a lot about this. 12 years he's been doing this.
And Ian, also Ian reminded us that Sean's making a chamber, a cloud chamber to see this.
Oh, they are Ian just said that. Are you making like a vacuum chamber or is it just a fog chamber?
I'm not sure. Yeah, that's a good question for him. Vortex mass not breaking any laws. Yeah, I mean, I think it's just uncovering new laws, new patterns that we just didn't, see before.
Well, here's the thing, and I'll say this about the laws. If you didn't know about the scalar being in here, and you just basically went and said, okay, I'm going to use transverse and longitudinal waves, then I'm going to use Steinmetz understanding, then you wouldn't know anything about the negative side.
Mhm.
If I didn't tell you there was scalar in there, you wouldn't have any clue where it was, right?
Yeah.
And
If it exists, you're not going to be looking for it.
yeah, you wouldn't know it's there. So how are you going to write a law when you don't know it's there? One of the things that mathematics does when they do this is they account for it, and they can't tell you what it is, but they can tell you that the math works with it because they accounted for it in there. Something was there that they saw, that they built out in the math, but they couldn't tell you what it was. Now we have it.
That makes sense, though. Just a natural progression of what, this field of study would have been if, the information wasn't suppressed.
Well, it kind of tells you the story when you go to look at it. So it says right here, Sean is making a cloud chamber. I'm not sure if it's evacuated. I have a vacuum pump and all the attachments for it. I was going to make a big one. I wanted to do 3 feet by 3 feet, and I never got to it. So I might have to take up that crusade once Sean does it. I can't let you guys get ahead of me, so I'm gonna have to start building what you guys are building a little bit,
Yeah. I mean, Ian and Sean are just on another level than I am. Like, I'm sitting here cobbling together parts, and they got these nice, classy boards that they're building, and they've been doing this for years, so that they're like vets, man. I mean, it's, I don't have to tell you, Sean's got some really nice looking coils, and Ian is like meticulous with his boards. They look so nice. So
yeah, super chilled alcohol, a little bit of dry ice.
Hey, Lulu.
What's up, Lulu? We saw Papa Bale in there earlier, man. I wanted to say hi, but we were doing the presentation, so.
Oh yeah, I must have missed him. Damn.
Yeah, he shows up early, man. I usually, stop, but because I watch his show all the time, he always says hi to me when I go on there, so I always like to return the favor. So, anyway, Ben, why don't we get into some of the stuff that you're working on here?
All right. Well, I can start out with going over some of Michel's recent videos and an attempt to get his subscriber count up. So I'm going to put the link to his channel in the chat in a moment. It's Michel's Bench. So he has a very new channel. He's only got like 27 subscribers. So I'm really hoping to get that up. But because he's literally got some of the most amazing designs that I've ever seen. And we're going to be trying to get some of those kits out there to you. And everything is, in the public domain. We're going to keep it open source and put out videos to show you how to make it yourself if you don't want to buy it from us, But we've been working together and trying to give some solutions to people regarding energy, just affordable energy, renewable energy, off the grid solutions for emergency purposes, night lamps that are very cheap and efficient, stuff like that. So he's been working on a couple of variations of his own design for the Tesla pancake coil. And I want to show those to you because they're really, really cool.
So Ian said that there's still a lot of confusion on scalar fields. Yes, Michelle did do an awesome display on the scalar field, and I'm hoping he puts that one up soon. Because I looked, and I was looking directly for that one.
All right, so I'm going to put his channel in the chat. That's Michel's Bench.
There you go, guys. Sorry, Ben.
No, you're good. Let's bring up this. There we go. So this is his new invention, the pancake caduceus coil. So this is really, really cool.
I wanted to share my new invention, and in this I also wanted to say that I'm releasing this invention to the public domain.
Ben, can you put on closed caption?
Coil cannot be patented.
Thank you.
And so everyone can use it and experiment with this coil. So this coil is called a pancake caduceus coil, and so it's a mix between several coils. So I'm going to show you my inspiration. So this here is a caduceus coil. I'll try to zoom out a bit. So this is a caduceus coil, and it's you can see at the end here, it's one single wire crossed and at specific nodes, node point here. So this caduceus coil produces scalar fields. So this is one coil that I was inspired from. Then I also was inspired to build this coil here. I was inspired to use this is a crystal radio spider web coil. It's a single wire, Litz wire, and it's just wound around on odd spokes. So what happens is when you get back to the start, it changes direction. And those are really sensitive for a radio frequency. And when using the antenna, there's absolute amazing quality of reception with those 1940s crystal radio spider web coils. So that's the second one that I got inspired from. And the last one is the Tesla pancake coil. So just a bifilar Tesla pancake.
Oh, that's cool.
Frames here, 3 stacks.
I know. It looks so cool.
They are connected the conventional way. So
and he made all of these frames custom based on the winding requirements, and he's gonna walk us through, you know, how to do it all and how to wind these coils. It's really, really, like, I'm very impressed with his work. And if you notice in the background right here, this is the platform, the prototype for the Tesla lamp that we're going to be putting out, the do-it-yourself kits for you guys. And we'll be going over that circuit and all the information regarding how to build it from scratch in the near future.
Inner wire is connected to the outer of a wire. And so this mix of
Ben?
Oh, my bad. My mic was off. So you see this little stand right here in the middle of the transistor and the light? This is actually a stand for the coil. So you can easily swap out your coil and have different design coils for the lamp, which is really neat, I thought.
Oh, absolutely.
Yeah, so everything that he's been designing has been wonderful. This is honestly, it's not going to be the final design, but we're going to make it like a steampunk theme kit, you know, like maybe like a Tesla ball, but old-fashioned incandescent.
3 types of coils end up breeding this coil.
Yeah, I can't wait to do these, to test these out.
Pancake caduceus coil. It's a bifilar, so the 2 wires.
Oh, and real quick, since these are bifilar, or at least this one is, I'm pretty sure. Yeah, he just said it was bifilar. I'm not sure about the other two, but as long as it's bifilar, it should work with the lightning thief.
Go through here, and then 1 wire will go to, let's say, the left side, which is this way, and the other wire of the bifilar goes the other side. So they sort of both weave like a DNA strand. So every single row at every node points get crossed. So those two bifilar go opposite side of this spoke. So essentially they cross every time at each node points here they cross. So the bifilar itself is crossing each spokes, and they're both going counterclockwise, but they're just weaved the opposite way of the spoke, so they always cross. There's 11 spokes. There's about 14 meters of 2 wires. Then at the back, they are connected the way that Tesla connected them. So one start wire gets connected to the end of the other wire, and I've center tapped it. So there's 3 wires here. So there's 1, 2, and 3, and this one is the center tap. And so the reason why I've done that is so that the current goes in both directions. Not only this, but it will go in both directions, and then they intersect like a caduceus coil. So it's a pancake caduceus coil. It will be creating scalar fields. There's a mostly AC field going on everywhere, essentially. But depending on, I've got an inductor coil here. So depending if the coil is aligned this way, we'll have AC field. But if the coil is aligned this way, we get a DC field. But all across here, we're getting a field, and in the center, the field is concentrated. So this is my invention for 2025, which I will provide the frame in the link description for use. And I hope you'll have fun building those. And I've also built this nightstand here for this coil. It doesn't really need any tuning. For some reason, this coil will resonate at a lot of frequencies very easily.
This is the most interesting thing about the coil I found. You basically plug it in, and he says it has such a wide range of natural resonance that you don't really even need to tune it.
Well, they're built the exact same winding, right?
Yeah.
He said bifilar, so each winding is exactly the same size or same length.
Yes, exactly.
Yeah.
Also some really interesting things that we can do with this coil. And I'll probably mention it in maybe the next few videos. But for now, yeah, enjoy, have fun.
So that is a update on the 3 coils that he's working on, his own designs, which are really cool. And then I have one more video, or actually no, let's
He's got that scalar video in that thing he made.
Yeah, these are both really good videos. So yeah, let's watch this one.
John
This one isn't that
Bedini
long.
Invented this.
So real quick, Ben, before you play it, we need to do like a GoFundMe for his mic. No, nobody can hear him.
Oh, oh yeah, that's let me put on the closed captions. Yes, I have a couple of recommendations. This HyperX that I'm using isn't that expensive, and it's a pretty decent one.
Oh, you could just get a little mic that goes on your shirt. They're like $10.
Yeah.
They're $10.
Yeah,
man. They work great.
It depends on what kind of setup you have, but yeah, he probably would do better with one that's pinned to his clothes or something like that. Whereas if you're sitting down, you probably would like a desktop mic.
Yeah.
The only reason I like the HyperX is because the RGB lets you know when the mic is live. So
Yep. Okay, Ben, play it. Let's learn some stuff.
Gluing 2 North Pole magnet together.
this is
and wrapping the coil around.
an interesting video.
he had a patent pending
He's talking about Bedini.
for using this technique for improving the quality of audio on CD-ROMs for music CDs. So this is John Bedini's idea and creation, and I'll show you a more raw version of what the coil looks like. So I've got it here. So here, if you can see on the video here, there's lots of items glued on this, been picked up along the way. So we've got two magnets glued on the North Pole, and then we've got a coil wrap around 120 times. The coil is 0.355 millimeter thick, wrapped around 120 times, and that is it. So that coil here is what we've got in the yellow box, just nicely wrapped, not like wrapped in a rush. But in the article about John Bedini's invention, this way of gluing the magnets and wrapping a wire around, if we feed an AC current into the coil, this coil will then, the magnet will then produce scalar field from the North Pole. So we'll have scalar field coming out on both sides of the magnet. So this is an invention from John Bedini. In the article that I'll post in the description, and you can read, you can replicate it if you want. It was mentioned in the article that putting a glass of water next to the scalar field would change the taste of the water, and it would also change the quality of the audio of the CD-ROM discs. So it's a really interesting device.
Hey Ben, can you rewind it just a little bit?
The reason why I'm here,
Right. Okay.
it was mentioned in the article that putting a glass of water
Right there. Pause it.
field would change the taste of the water.
He's talking about structured water with scalar fields.
Yep.
So when I tell you about the water, when I put this stuff in water, and you've seen all the experiments, right?
Mhm.
It's structuring the water with the scalar field. It's also communicating with the crystal itself. So
Wow.
he says it right here. And if you take this stuff and you put it into your cup of water or jar or whatever, put a jar of orange juice right next to it. You don't have to interact the two, just set it right next to it. Your jar of charged water will actually taste a little bit like orange juice in it, like a flavored water would.
Interesting.
It does transmutation because it's scalar.
Almost like it has electrolytes in it or something.
That's charged water, yeah.
That's cool. Let me play the next video, and I think that's the last one that he has.
Make it wide.
Because I'm seeing some increase.
This one's a little
in
long. I'm not going to play the
voltage
full
and
video.
increase in current with about 1 milliamp current increase and half a volt.
So real quick, he's describing that he's picking up apparently a slight increase in amps, while he's picking up an increase in voltage as well. So that's, like we're still trying to, determine if we're reading all this right. But he's got a no-scope, and he's got a lot better equipment than I do. Yeah, this is interesting stuff.
So he's running the yellow one there and the one on top of it?
I believe so. You
Or
know
he's
what?
just using it
I'm
as a
not su-
pickup coil?
I think he's just using it as a pickup coil. Let me rewind it. Let me rewind it and see.
Is his resonance close to each other?
Okay,
You know, I don't
so
know.
I just want to share some of my experiments, and I would be interested to hear what people have to say about this experiment, because I'm seeing some increase in voltage and increase in current, with about 1 milliamp current increase and half a volt of current loss, and it looks very strange to me. So I thought I'd make this video and
My bad.
see
He
if I
said
can
half of all the current loss. I thought
Hmm.
he said half of all the current gain.
get people's opinion on what's going on here. So I'll detail this box probably in the next, or within this clip. I'll insert the description of that. This is
So
my
pause it real quick, Ben. Okay. So if you know about resonance, you know about how a Tesla coil works. If you don't put it in the correct resonance, you're just wasting energy because the frequency of the number one coil and the number two coil isn't matched, right?
Right.
So
Have to be in sync.
there you go. So he's out of sync on both the coils to each other then. Therefore, he's wasting energy to try to push the energy into that secondary coil.
So he needs to sync them, and once he can sync them, you probably see a little bit different numbers.
Yep, that's right. Once he puts them in the right resonance to each other, his numbers on the secondary pickup coil will increase dramatically.
That makes sense. That does make sense. And I know Michelle probably watched this tomorrow at some point, but I'll drop a comment by his chat as well, and just let him know that it is. Nathan says it is possible.
Oh, it's definitely more than possible.
That's neat. Well, no, he specifically he's always interested in what you have to say, because like so much about this this energy. You've worked with it more than anybody that we've known.
Well, yeah, you got to first identify. Once you identify it, it's easy to break out. You probably watch like 30 videos on this stuff, and it's so hard because they like to try to make it complicated, and you have to break it down so it's easy to listen to.
Right. And then you and Gerald just make it a lot easier to digest for the layman like myself. But at any rate, there's still a lot that I personally have to understand about this scalar. But I'm going to continue the video.
Go ahead.
And it's just pancake coil that I've built. This is my new invention, a new coil. And this is a piezo transducer.
Yeah, so he's got the
resonance
piezo
frequency is
here.
28 kilohertz. And this is just a dual fifth circuit. There's a 5 watt, 220 volt UK mains light bulb on a ceramic base.
I think this is the same circuit as the lightning thief, only with just the open circuit or the closed circuit, one or the other. I forget. But I do believe that is the same circuit as the lightning thief that he's using right now.
Okay, he's got a transducer.
Oh,
The piezo,
except for the transducer. He added the transducer, yeah.
Yeah, the piezo is just that little disc with the quartz on it. This is
So that Mike said could like double the efficiency, or up to double the efficiency.
the little piezo, yes.
Yeah.
Well, hold on.
That's what Mike.
Let me explain this. So when you're in scalar, right, because it's an inverse, it will interact with the crystal. So when you look at it, the crystal itself is amplifying that field to double it out. So you're breaking the negative on it when you hook it up. It's like shorting it out. So what does it do? It's like it's going to fill up that entire coil to the max it's about to do. So you're going to saturate it. Then you're going to get more energy out of it because you're going to push that on. And the way Mike's works is as soon as you push it on, it
Mhm.
stops it from going backwards because he puts it right through a spark gap. So as soon as it
Yeah,
goes to
yeah,
that
the
spark
spark
gap,
gap.
it can't go backwards, right? It's like a
Right, 'cause it's
diode in itself.
diode. Right.
There you go.
Yeah, that makes sense. And then, well, the piezo transducer is, I don't know, like, it's a lot bigger than I thought it would be,
There's
honestly.
two different. There's two different parts.
But
There's a transducer, which is the one you're seeing right there in front of you, right under his arm.
Mhm.
The piezo is just a little disc. That there's no little disc there. That he's using a transducer.
Okay, and then there's what, like 2 leads that come out from it?
Yeah, one on each side, and it's just one negative, one positive, and basically you look at those sonic cleaning machines is what it's normally used for. So it just
Mhm.
puts out frequency in order to clean parts, but in this way, I'm not sure what he's doing yet.
Yeah, I don't know. Let's continue the video and see what he has to say, because I don't remember what he said in this video.
Okay.
I only watched this briefly earlier.
I will add a schematic of this connection in the description so people can see how it's all connected together. So this is just currently this setup here is just the dual fifth connected to the output. And I'm going to show you the waveform. Okay. So currently the volt peak to peak is 20 volt. And the waveform looks like this. And it is -3 volt and max is 15 volt. So peak to peak 19 volt. This is what's coming out of the dual fifth. Here we go. This is what's coming out of the dual fifth. And that's just standard dual fifth pulse. And we can look at the duty. So it's a 10% duty cycle and 91% of just an idea on the power consumption here. 11.67 volt at this current draw is not correct. This is coming from my power supply, and for some reason it's not accurate. So I've got the current hooked up from the positive wire from the power supply, so in line. So this is the correct current draw. It's 225 milliamp, 224, 225. It fluctuates a little bit, and the voltage is 11 volt, 11.68 volt. Okay. Now I'm going to connect the John Bedini's magnet coil, and you can see currently peak to peak is just 20 volt or 19.2 volt. Okay, and I want you to look at the brightness of the light when I do this. Okay, I'm going to turn the light off.
This is where we need a lumen meter. It's on the list. I'm gonna get one. They're not that bad.
The brightness of the light has gone up by a lot, and I'll do that.
Yeah,
again.
look at that.
Probably by twice as much, or more than twice as much. So it's gone super bright. I want you to have a look at the readings now. So I'm gonna auto set because this is inaccurate. So I'll just auto set again. Okay, that's a bit better.
Yeah, look at that waveform
So
now.
now the volt peak to peak is 62 volts.
Yeah, it's kind of hard. It looks like he's cutting off the bottom of it.
Yeah, it's all covered up.
Okay. What's also interesting is the mean voltage is -32 volt. We had -3 volt before. So now we've got an actual swing of -32 plus 30. So it's a nice negative and positive swing. Again, increase of 42 volts. Now I want to show you the power draw here. And it hasn't changed really. We're still at 225 milliamp. And the only thing that has changed is the voltage. It was at 11.69 and now it's at 11.3.
And it
so
went down.
It dropped. We've got a gain of 42 volt and we've got a clear increase in brightness with the same current draw. Okay, so this
Pretty cool.
This is anomalous. This John Bedini's magnet coil is anomalous. Does not make any sense as this is an inductor. So that's the first thing I wanted to show you, and I'd like your opinion on this. Now, the second thing is the piezo. Everybody's been talking about piezo, and everybody's rightfully so. Need to talk about the piezo. So here
Mike was right.
Piezo transducer. I'll turn the light off again. So
you want to pause it and tell us what Mike said?
Voltage reading again.
So Mike from Faraday Research said that he believed that we would see a significant increase in efficiency by hooking up one of these piezo electric transducers. So and that's what he saw. Like, he literally had a voltage drop on the input, the current didn't change, and the brightness went up. So like, it's pretty cool, pretty freaking cool.
And it's 11.33 volts, and the current reading is 0.225 milliamp. Now, the piezo transducer will only resonate at its resonance frequency. So this is, it will only resonate at its resonance frequency or an octave of it. So half octave or 1 octave above. So this piezo resonance frequency is 28 kilohertz. And at the minute, the system here, its resonance is at 32 kilohertz, okay? And the voltage peak to peak is 62 volt. By the way, I've probably forgot to show you what the waveform look like, or the signal looks like.
Oh, there we go.
It looks like this at the moment. So that's with the John Bedini's magnetic coil. So this is completely different from the pulsed Joule-fifth signal that we had before. Now we've got a huge negative swing and a positive swing, but also it looks like there's a lot more noise. And we can check the duty cycle. So now it's 67% duty on time and 32% off. But we're getting a huge increase in brightness and in voltage, and we have the same current draw.
So the duty cycle changed, and that's very important to note, because he's getting more positive duty and less negative. So I think that's indicative of tuning. You know, like you want that duty cycle to be as close to 50-50 with these coils, I believe, as much as possible, right?
And we've got 0.3 of a volt that has gone down. So again,
this pot might not be sensitive enough to tune it quite to 20 kilohertz, you know. That's what I think. Yeah, but
what is he at now?
He's at 32 kilohertz.
32?
Yeah, out of 20. 20 is the resonance for the piezo. So it's close, but it's still got some room for tuning. You know what I mean? So if you can get that pot a little more sensitive or a little more tuned in, you might be able to get that, in my opinion, you might be able to get that duty evened out more, you know? It's something that I noticed with the ABHA coil when I was hooking it up to the Lightning Thief and testing it. I did notice that it would switch by tuning it. It would switch the duty cycle, and it literally made it more efficient. So,
did it work for you?
Yeah, like, I mean, I don't know. It was really cool, but some really interesting thing that happened recently is I got a 0.6 watt bulb, and I tested it on the Lightning Thief, and the thing lights up no matter if it's in tune or not. And it's baffling me, because it's like, when it's out of tune, it's consuming such a low amount of energy. It's like in standby mode, right? The battery will last days and days and days, and it'll only go down like a tiny a bit, you know. Very efficient standby mode, but it in standby mode and appearing to decline at the same rate or near the same rate, the 0.6 watt bulb is lighting up. So It's interesting, but I have a feeling that's because the bulb also has multiple lights that pulse. So I think that like one pulses on and the other one pulses on, and I think that oscillation might be allowing it to tune in even more. I don't know, because it's humming. Like when you hook up the coil to a Joule thief circuit, you'll notice the circuit hums, but the light bulb never hummed before until I tested this specific bulb, the 0.6. So very, very interesting stuff happening.
Yeah, I'd say it is.
And so this is what the signal looks like. Okay, and the volt peak to peak is 62 volts. Now, going back to the piezo, I'm going to connect the piezo this time. So what we've got is we've got the output of the Joule fifth. So it's sort of high voltage, and the frequency is 32 kilohertz at the moment. It's going to the John Bedini's magnet coil. Okay, back again. Just looking at the piezo. So I'm going to connect the piezo, and so the voltage is 62 volt peak to peak. Current draw is 0.225 milliamp, and voltage is 11.33 volt. I'll connect the piezo now. Again, the
Wow.
notice
And you
the
can hear
brightness
it.
of the light.
He completed the circuit.
Yeah, and you can hear it. Listen how loud it is now.
Much brighter now than with just the John Bedini's magnet coil. And the voltage, just try
And it's
to
dancing
set
the
it
wave.
again.
Oh, I can hear it now.
Okay,
Mhm.
so
And look at the duty.
there's a bit of a swing.
Look at the duty.
Currently between 69
Wow.
volt and up to 80 volts. I'm gonna try to stabilize this if I can.
Yeah, it's a little jumpy, but if you could stabilize it, look at that.
The voltage is between 68 and 80 volts. I'm going to show you the current draw quickly. And the current draw has not changed. It's still 0.225 milliamp. And the voltage, from the original Joule fifth, the voltage has gone down by 0.3 volts. So with the piezo and the John Bedini coil, we're getting a lot more output, and I'd be interested to hear your comments.
So that's Michelle's bench. I'm gonna put the link in chat again, just so everybody has it. I want everybody who's interested in that stuff to go over right now and subscribe to Michelle's channel. Let's get his sub count up. In the meantime, I'm going to load up a couple of videos from my own updates on the Lightning Thief. And
right on.
I'll close it with that. Let's see.
Yeah, I already subscribed to him, man. I want to get with him on the scalar thing as we keep going back and forth. I think it'll be very, very interesting conversations as we work this out.
Yeah, it's coming together quite nicely, and we got a lot of interesting stuff that we're going to be releasing to you guys real soon here.
Nice.
As soon as I get everything situated. Wanted to get this on camera before I fuck it up.
Oh, yeah. Hello.
Toggle switch. Oh, of course.
Okay,
the
we can
AC
cut that
or the
out.
heat key kicks on when I'm recording. Okay, here's a toggle switch.
So I put together one of these earlier, and I did screw it up. Like it worked, and then before I caught it on video, I don't know. I think I blew up the transistor. I was doing some probing earlier, and I think that's what happened. So yeah, I was kind of frustrated. I was like, let me get this on video before I screw it up again.
We've all had
Recording.
those
Okay.
days.
Yeah, but I did. You can see it's a Frankenstein version. It's a very, preliminary, rough draft. But it's got all the female connectors, so everything on the board is basically replaceable. You can replace the neon at this point if it burns out. I don't have to waste any components. I can test with this thing. And it's got the toggle switch on. So, and you'll see in a second, there's at the end of the board on the right, there's 2 squares. There on the top, there's the open circuit, and then on the bottom, there's the closed circuit. And we want you to be able to toggle between the two. And you'll notice I haven't actually done much testing with Ian's cat board, but I have it all set up, and it's all ready to be tested. So that's next. But here's this video.
So here's the toggle switch. Ooh, and that's the closed circuit method, baby. Ooh, baby. All right, let's turn that off before we fry something. As you can see, everything on the board now is swappable. This is just a very rough draft, a very rough cut of the prototype. Everything will be more neatly organized with professional proper terminals. So we'll have the proper terminals, female jacks input into here instead of these makeshift female jumper cables from the Arduino kit I have. I have the resonance of this Mark 1 coil already, so I ran out of potentiometers, the 1 mega ohms, so I just went ahead and put the resistor there, so we don't have the ability to actually tune it right now.
So yeah, I ran out of pots. So with this circuit, you can, this is something that I'm going to implement with the banana sockets. Once you get the ohms, the resistance, once you're in tune, you'll get the resistance by plugging in your multimeter to the banana socket, and that'll be able to tell you what ohms you'll need to replace the potentiometer with, and you could just do what I did and just always have it in tune if that's what you're using it for, But again, it's going to be, customizable.
But when I get another pot, I can just easily swap that out. So that just unplugs, and like everything, this is the diode, this is the 1K ohm resistor, the transistor here swaps
I know it looks
out.
a little funny right now.
Everything's going to be able to be everything's going to be swappable on the prototype I'm going to send out to the team, and the consumer version is going to be aimed at that as well. I don't really know what the consumer version is going to be like yet, because we have testing to do to make sure that the configuration is configured properly and optimized properly. So at the end of the day, there could be changes that we make depending on what we see in our testing. But everything to this moment is swappable. You can see I have the 3-pin toggle switch to toggle between the open and closed circuit method here, which is right here. You can see the closed method and open method, and they're connected with this wire, this white wire, and the white wire is a Y junction that I soldered myself. So you have both connected to the common ground, and then either gets the positive for their respective circuits. So you can toggle between them, see? Now I did have the toggle switch working and implemented into this case here, but unfortunately something happened. One of the connections came loose or something. I'm gonna have to look at this. So I just redid the board, but it was working on this one. So I'll have to figure out what went.
Just wanted to show you that quick part 2 clip, because it shows you what the toggle switch is going to look like kind of when it's on the board. It's going to be on the bottom there, and again, these wires are all not going to be there. They're going to be like terminal blocks, so
Right.
You'll have screw blocks. Yeah. So that's going to be the Tinker version. The consumer version will have like USBs for the output on the load, and I'm thinking an eighth inch auxiliary, 2 1/8-inch auxiliaries, one for each channel on the coil, and then a standard 12-volt DC socket. And and 2 banana plugs on either side. So yeah, it's going to be pretty cool. I still have a lot of experimenting to do to make sure that it doesn't look and run like crap. So some of the cases are kind of messed up. That's why I chose this one, because this one was a little bit messed up. So I was experimenting, just trying to see if I can get the components to fit in the casing and how they would, fit, and, get an idea of the spatial reasoning and all that. You can see that one of the problems with the Lightning Thief will be the neon. If you don't have a load connected to it and you leave that neon on for extended periods of time, it will burn out. So, we want it to be swappable, obviously, if you have to replace it. But yeah, that's just something to pay attention to. If you don't have a load attached to it, in about 24 hours, usually, if it'll give it a total about 24 hours and before it burns out completely.
Right on.
Yep. I think that's it. I had one more thing. Let's see. Let me close this down. So
I like that better than the breadboard you had in there.
yeah. So Sean has been an inspiration for us all, following in his footsteps. I'd like to end the presentation with a cool fact that I didn't know before regarding plasmoids and shrimp. So pistol shrimp, I recently found out, have the ability to produce bubble cavitation.
Really?
Yeah. So I have a video. I'm not going to play it, but if you guys want the link, I'll put it in the chat. Oh, I have to put Michael's link in the chat again as well. Let me put that in there real quick before I forget. That's Michel's bench, or I'm sorry, Michelle's bench. And I'm going to put the link for the pistol shrimp video in the chat. I'm not going to play it, but I'm just going to go over real quick something cool that I found out today. So cavitation is the process of creating bubbles in water by snapping the pistol shrimp's claws shut. The bubbles collapse, causing a loud snap, intense heat, and light. So a loud noise, intense heat, and light. So this is creating bubble cavitation in the realm of the star in the jar experiment. It's creating a plasmoid. So it's literally using bubble cavitation as a defense mechanism. And I think that is really cool. How nature utilizes basically free energy, bees and beetles, and we just kind of like go out through our everyday and largely ignore these miraculous things they do, So real quick, how it happens. Pistol shrimp's claws snap shut, creating a high-speed jet of water. The water speed causes the pressure within the jet to drop below the water's vapor pressure. Tiny bubbles expand into a cavitation bubble. The bubbles collapse, creating a shock wave that can immobilize prey. So it produces a loud sound, light, heat, and pressure, which is all what the star in the jar experiment produces. And how plasmoids work in bubble cavitation in general. So they use this for hunting and communication. I just thought that was really cool. And if we can't get this thunderstorm generator off the ground, we can always consider pistol shrimp powered hydrogen cars. I don't know.
Ben's gonna have his car with a bunch of little shrimp in there. Come on, get me going.
It'd be like SpongeBob. La 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 la.
Oh, that's terrible.
Ben, any bloopers? I always got bloopers.
Oh,
Pistol shrimp's duty cycle. Oh my god, you guys are hilarious.
oh yeah, they got you on that one, Ben.
Yeah. Oh man, I love you guys. You guys are so fun. I had so much fun on this podcast that we do. But that's all I got for today.
Oh yeah. So yeah, that's gonna be cool, man. Shrimp cars. Huh.
Yeah, shrimp cars.
Nah, get close to the end of the life, you just eat them, huh? Yeah, forget all this free energy. Let's just go get some shrimp, put them in our car. I'll get little fish tanks under the back seat.
We're gonna be using shrimp power instead of horsepower.
Yeah, we won't have that little fish on the back. We'll have shrimp.
Yeah.
great.
Yeah, I gotta make a new emoji now. Oh, Joe says mantis shrimp do it too. And they look cooler. They do look cooler. They're like multicolored, aren't they? That's the multicolored shrimp, I believe.
Oh, I'm sorry. I'm reading something. I was reading
No,
Ian's
you're
comment.
okay.
The rod essentially expands the voltage field in the 0 point. So I'm not sure exactly which one he's talking about here, but if you put a bigger rod in there, then you get more heat. So if you get more heat, you're going to get more voltage and amps, and that's why it goes to Smith's invention. Don Smith, I believe his name. And it changes the field completely. You go from a scalar cold to a regular heat energy. So I don't know if that's the one you're talking about there, but if you're just looking to convert, you want Don Smith. You want to create that energy exactly like he did. And several resonant coils along with each other on the number 1 coils where they'd be. You want the number 2 coil, you could just do it with the regular wire with the coating on the outside. You don't have to do it with the magnet wire necessarily, not in his anyway, and then still be able to pick up the field. So I'm not sure if that's the one you're talking about, but you could get a lot more energy out of that. And then once you get that energy there, you wrap it back to the center and it'd be able to push it out even more energy that's coming out of there. So not sure if that's what you meant. You'll have to get with me later, Ian, and let me know. Okay. Ben, you still there?
Kind of.
Kind of.
I was reading.
Oh. So yeah, by the way, I just wanted to let you guys know that ultrasound for my gravity flyer was actually a jewel thief circuit. So when I went to test it out, I opened it up and looked at it and I go, oh man, look at this. So there's an iron ferrite core, there's a round one, and it's got a bunch of wrappings in one direction and then 2 counter fields wrappings in the other.
Wow.
And it's saturating it. So when I hooked it up to my oscilloscope, I was able to tell you exactly where the saturation is. And then it also, as you turn the dial, it has a Tesla coil ring on one side and another one on the other. So you know exactly where you're at, and where the amplification is going to be is in between those two. So it was really cool. So I wanted to use it on my rodent coil as well. I wanted to see if I can't pull that amplification out of there. So that was a pretty interesting thing. And by the way, Ian, I know
that was the ultrasound device you were shocking yourself with?
No, that's totally
Oh,
different.
that's something different.
That was just fun. So this was something that came out from my gravity flyer project that I've had for a long time that Charlie C made for me. And because I didn't build it, I didn't realize what it was. You know what I mean? Charlie C sent it to me and I had it, and I opened it up recently and I go, oh, really? Well, that's really what that is. So once I do that, I was able to amplify it real quick on what I needed to do.
Yeah, there's such an amazing simple circuit. They're so versatile. You can use them. I don't know. Like, I'm having so much fun with the Jewel Thief circuit. Like, it's really cool. And we've only scratched the surface in terms of what it's capable of.
Yeah. Well, it's an amplification circuit. So that's why you would use it in a lot of these things in there. That's why they used it, is because it's made to saturate the coil itself. So once it's saturated, you're going to get a lot of energy coming out of it. So when you start hooking in piezos to this kind of stuff, like Mike did, if you put in one on each side, like, you know, kind of like a north and a south pole on it, and then your coil's in the center, man, you should be able to just tap back and forth all day and amplify the daylights out of this thing.
I wonder if those piezo transducers, can you get them a little smaller, or is that like the smallest they come?
Okay, hold on. You keep confusing the two. There's a piezo disc, okay, little round disc, and it has crystal on it. And then there's a transducer, which is the big metal object that he had. They're
Yeah,
not
the
the same
transducer,
thing.
you can't get that down, can you?
That's about the size they come in. But you can get the piezo. That's what you need. That's what Mike's using. He's not using the transducer.
So you don't even need the. Okay, you just need the disc.
Yes. Just a
Yeah,
little bit.
because well, I'm thinking, if we can get one inside a case, like it would be nice to have a little small electric or a small piezo disc in there. But if we had to have that big, transducer, like that make it bulky. So
But you don't want it in the case. You want it over the coil.
oh, you put it over the coil. Oh, okay.
Well,
Well, either way, I want to make sure like we don't make it bulky.
No. Well, it's kind of like it's putting a tripod on the top with the little disc, is what it is, and the same thing on the bottom. And it's just, if you pull negative energy through this or the scalar, like I'm telling you, it interacts with it. As soon as you tap it, it takes the energy of the coil and goes boom, boom, boom. And that's what you'll start seeing happening. Okay. That's what's going on. It's amplifying it. So it's a natural over unity device, is what Mike calls it.
Yeah, he said he doubled his output, didn't he? Or he doubled his efficiency or something like that by attaching one of those things to his device.
Well, that's what I just said. Yeah, you're amplifying it. So you're taking your top and bottom. So when you look at your oscilloscope and it says 160, okay, now double it. So it's going to be 320 on that side, but it also doubles the bottom side. So you go like this on both sides on your oscilloscope. So yeah, it's amplifying it. So just like Bedini, you catch the spike and you put the spike, you know what I mean, in the capacitor, and you're able to pick up more energy that way.
Wonder where I can get those. Where do you source those?
Amazon, under $10. You could get a pack of them.
That's not bad.
No, not for what they do. You already got the jewel thief circuit.
Right, exactly. All the expensive stuff's out of the way. That really the most expensive part is the transistor and the pot, the potentiometer, so.
Yeah, and remember, you're just breaking the negative. So go over to the negative side and put it in, you know what I mean? Right in there. That's all you're doing, is the on and off of the negative is what you're breaking. The positive stays on.
Right. So you would put it kind of like in the same realm of where you would put a spark gap?
Yeah, if you use Mike's spark gap system, absolutely. It's right around there. Yeah. Let me see if I have that real quick, and I will show it. Let's see if I have it right here. I may not. Oh, this thing, every time I go online, it messes up my front page because I have to switch the computer.
You've been switching on and off those transistors too with that Tesla coil.
Oh my God, dude. I set that thing back up today. That is such a wild experiment. Like at some point, my computer's going to have enough, and I'll be buying another motherboard. So, hang on. Maybe I put it in a different area. Give me 1 second. I'm almost there to it.
So Ian says a good analogy for the piezo disc is holding a microphone in front of a speaker, the feedback loop.
That's right. So there's Mike's circuit right there. His pulse motor circuit. You can see the piezo in there.
Yeah, it's in parallel with the okay. That makes sense. Okay, and then where would the spark gap be though? On the same in the same area or?
Yeah, his spark gap is
Yeah.
his switching. So I'm trying to see where it says on there. It doesn't say where his spark gap is on there. Let me see.
But I can imagine it's on that same negative line, right? I mean, it acts as a diode, so
It may be that little slash with the circle around it right there.
yeah,
I
yeah.
think that's where it is, but I don't think he marked it and named it.
Well, we'll ask him next Friday. But that's interesting because I definitely want to test with one of those piezo discs. You know, and one of the tests that we're going to be doing this week also is testing Ian's cap bank, specifically with the stereo amp board, because yeah, no, I don't know if the Lightning Thief will actually work with Ian's board, because the capacitor is or the capacitance required for the Lightning Thief is around 330 picofarad. So it might be a little bit too big for that. But the stereo amp board requires 0.15 unifarad, and I might need to adjust it from that range, which is perfect. So the board would suit perfect for tuning the stereo amp method of the coil, which I think is going to be cool because I know if you guys been paying attention to my research recently, we got the stereo amp method to produce high voltage for the first time, exciting like what three or four neon lamps.
Nice.
Yeah, but the thing is, it wasn't getting much current, and it wasn't lighting up much of a load. You know, in terms of the 40 watt. You know, like the Lightning Thief will light up the 40 watt about 25% or whatever.
Yeah.
But this wasn't lighting it up at all. I think maybe I just need to adjust the capacitance, and Ian's board will be perfect for that.
Nice. Yeah, see, I got a bunch of boards Sean sent me for different ZVS drivers. And as I build them out, this is so much easier than what I use now. So what I use now is specifically set up for my Tesla coils and resonate in a certain range. But what this will do is allow me to set up things that are much shorter on coil. So let me grab this one and I'll show you. This coil right here, this number 2 coil, it resonates somewhere in the 720 kilohertz range because it's 28 gauge wire. It's about 12 inches long with a 2-inch diameter, 2.5-inch diameter in it. So it's relatively small, but the smaller you get, the higher the kilohertz, right?
Right.
So if I wanted to get into the megahertz or something, I'd be dropping it down, around this size. I know it's got one in the terahertz like this. It all depends on wire size and capacitance and stuff. So that board's going to be perfect for making this stuff work. Just, you know what I mean? Top notch.
Oh yeah, and it's gonna save you all hours of frustration trying to work out the tuning and all that. I know it's gonna save me a ton of time. So thank you, Ian. That's really generous of you.
Yeah, Ian. That board's going to save me a ton of time. I'm going to go ahead and work on it and then throw it up on there for you, Ian, so you can see it. But yeah, we're going to really get this thing rocking. Now I'm going to be able to do stuff Sean does.
Yeah, no, I might even I don't know, maybe if I have time Wednesday, I might go live and do like a lab or something with the board. Or maybe on if we don't have a guest for Wednesday or any presentations lined up, maybe I'll do that.
Well, Sean usually has a presentation going on, but after that, absolutely put it on there. And if you're available on Wednesday, if you're off later in the show, like after the first hour, by all means, come on and show it off.
Yeah, so I'll do some messing around and see if I can get anything. But if I do, I definitely want to do a demonstration, sometime this week.
Yeah, I got a lot of work to do this week. Since all the fires and stuff are out here in California, our power keeps getting shut off. So
I was just gonna say I saw you post that.
Yeah, I'm a bit far away from the fire. It's over the hill, I should say, which probably means 60 miles, something like that. but it's the rolling blackouts that they got going on. They keep shutting off everybody's power for like an hour or two at a time. They say it's for the wind. I don't buy that. So we've had harder wind out here. They're probably just worried that there's energy somewhere that they need it for.
Right.
So.
Yeah. And also the smoke, like even if you're not in the immediate danger, it could be, harmful to go outside for extended periods too. Breathing in all the smoke.
Thankfully, it's blowing towards the ocean. It keeps it away from me.
Oh, it is. Oh, thank God. Okay. Well, I'm glad that you're okay.
Oh yeah, I'm fine. It's a huge inconvenience, and then you got family members that are over in that area, so they, they have to come down, to get out of it. So you always accommodate everybody, and it just works out, man. And
so, no, I know how that is. You accommodate everybody, and then they actually bring a party, and so suddenly you're hosting a party.
Oh, dude, it was so bad. The power was off. I turned on my diesel, man. I turned on my generator right there and just powered it up, man, so that everybody had, my mom needed our air machine, stuff like that. So we got some stuff powered up in here, man. So
nice.
Yeah. Anyway, that's it. We're going to keep getting through it, man. As long as they don't shut off my power when we're doing these lives, man, we're good to go.
Yeah. And if you have access to an APU, sometimes that would help, even if just like 30 minutes or an hour, sometimes, you can get a one that'll hold a charge for your computer,
Yeah, well, the one thing I didn't do is that we have solar panels on the roof, right? Mm-hmm. I was too cheap at the time to get the battery backup with it. So I'm going to invest in that so that we just have it for the house.
Yeah. And then once you figure out how to do the one wire energy through Wi-Fi, you can just get your internet for free.
Well, we won't tell the government what I'm doing. Okay. We won't announce it.
That was a joke, ladies and gentlemen.
Yeah. Oh man, Bill's got a few tricks up his sleeve for this stuff, okay?
Your Tesla coil literally falls out your sleeve.
It'll be hanging on the walls like candles, man. You know what I mean? Nathan turns on every light in the house with his Tesla coils all over the place.
Oh, I see. I could see your neighbor like, what the hell are the lights going on and off?
We got no power and I'm over here just blinking.
Or the garage doors opening and closing.
Well, yeah, you don't see anything but you see a glow around the doors when I'm in my garage all the time. So, I'm doing something. You just don't know what I'm doing because I blacked out all the windows.
Oh, man, that's funny.
Oh, man. Right on. All right, Ben, it's been 2 hours, man. I'm about ready to take off. I got a ton of work to do today.
Same here. It's been real fun. I love doing these podcasts with you and everybody else. It's the highlight of my week. It really is.
Yeah, hopefully Gerald will be back soon. I talked to him just recently. He said he's just swamped with work. Going through some changes. His wife was laid off, so I think he's working double. And they make that bread and stuff like that for people. So I think he was setting that up. I could be wrong. He'll tell me. But, yeah, he's got some stuff going on, so he may miss a little bit longer before he's able to come back on and do this with us.
No, that's fine. Everybody's got stuff going on in their life, I recently lost my job and I started a new job. So it's, my schedule is going to be kind of rocky. There might be a night that I miss or two, but we'll pull through it.
Yeah. That's what a team's about.
Mm-hmm.
All right, guys. I want to thank everybody in the chat. You guys have been awesome, man. I had a real good time playing in the chat today. Ben, thank you as always.
Oh yeah. Thanks, chat, and thank you, Nathan. I appreciate you in your presentations. You really opened the door for scalar energy understanding.
Right on. Big shout out to Ian, guys. Thank you very much. Have yourself a great night.
Yes. Good night, everybody. Good luck.